Okay, so your definition is the rate of diffusion. I know there's more, but diffusion was a special type of diffusion, right? What did it require? A small hole. Okay, good. So fusion is the escape of gas through a small hole. Example. Where would you find a scenario such as this? A balloon. Something with just a, it's got gas in it. You know the gas escapes through tiny holes, right? So at the bottom of the balloon, I have the hardest time tying those things up. But it could be through there, or just, naturally the latex kind of starts to wear and you get a small hole. So you got your B-Day happening, somebody puts a hole in your balloon, and then out comes the gas, right? Now, we already know how the gas travels, right? So if I put carbon dioxide in the balloon versus hydrogen gas, that'll be an awesome burly balloon. Okay, you put carbon dioxide in the balloon versus hydrogen gas, which balloon would last longer? CO2, because it doesn't diffuse as fast, so therefore it diffuses at a slower, or diffuses at a slower rate, right? So this is relating us back to the information we talked about kinetic energy. 1/2. Remember this formula? Yes, mv squared. Good. So increasing the mass does what to the velocity? If the kinetic energy, kinetic energy is directly proportional to what variable? The kinetic molecular theory told us so. Kinetic energy, the energy of motion, is directly proportional to the what of the room? Temperature, remember? Increasing temperature increases the craziness of the gases. They move faster. Do you remember this? Yes. Okay, just in case, kinetic energy is directly proportional to temperature. So at standard temperature, at whatever temperature we say the lab is being held at, the kinetic energy is always the same. So these gas molecules, the only things you can vary are their mass or their velocity. So increasing the mass of a particular gas, or choosing a gas with high mass, will decrease the velocity at which it can travel, right? So that's why the carbon dioxide, the balloon will last longer with carbon dioxide versus hydrogen gas, right? Okay, so that's what diffusion is. Let's go back to the Graham's law. So the rate of diffusion of any gas is inversely proportional to the square root of its molar mass, right? So we've got a little bit more math in this one, but I'm going to write down the law below exactly as it's stated here. So the rate of any gas is inversely proportional. So the rate of any gas, I'm just going to call the gas A, is equal or is inversely proportional. So if this is a numerator, then the inversely proportional will be in the denominator. So inversely proportional to the molar mass of that gas. That's what the definition says. Okay? So basically, it's exactly what this whole kinetic energy formula is, because this actually leads to this formula. You can derive it. But if you have a high mass, there's a large denominator. Large denominator does what to the rate? Makes it bigger or smaller? Large denominator does what to the rate? Smaller, slower rate, right? So if I had a little bitty gas, small molar mass, what would it do to the rate? Increase it, right? So a low, like if you're doing 1/1,000, it's going to be a really, really tiny number. But if you do 1/1, fairly large number. Okay, so this is the true definition. But most of the time we don't compare, we don't just talk about one gas. We talk about comparative gases. So for example, you can compare gas A and gas B in a version of this, but I'm going to compare them, so I have to do both rates at the same time. So it's rate A over rate B is equal to, which goes on the bottom, A or B? A, so the molar square root of the molar mass of A. So then B is on the denominator over here, so it's on the top over here. Molar mass of B, right? Square root of molar mass of B. It's just inverse, so they have to go crisscrosswise. This is the one you'll be using 90% of the time. You may use that. But this one's a comparison. We like to compare data. So if I gave you hydrogen versus carbon dioxide, your choice, it is your choice to choose which one's A and which one's B, but I always choose the lighter one to be A. So the lighter gas, the one that weighs less, will be A, because then you'll get better quantities, calculations. Because, like, for example, you'll say hydrogen gas moves or fuses at 4 times faster than this, versus like carbon dioxide gas moves at 0.5 times faster. Like the decimal part doesn't make a whole lot of sense. So I tend to put the lighter one on top and you'll get better values. 2 practice problems? Ready? This is Graham's law. All right. So for this one, it's the relative velocity once we're comparing. Dang it, I just did 6 examples. Okay, so what is the relative velocity, aka the rate of diffusion of hydrogen gas to carbon dioxide gas? First equation or second equation? Which one are we using? Second one, right? So rate of who? Who am I going to call A? What? Lighter. Hydrogen gas, right, is diatomic, don't forget that, over the rate of CO2, good carbon dioxide gas, is equal to what?
Square root of mole mass of CO2.
So molar mass of CO2, so you're going up over here. So the top one is molar mass of CO2, which is 44 grams per mole. Good, so you just added carbon plus 2 oxygens. And then over the molar mass of, which is 2.016. Super special here, okay? So you're just doing crossways, right? So this is hydrogen gas in the denominator here, carbon dioxide mass is in the numerator here. Okay, so let's simplify here. The rate is equal to the square root of what? About what? What's 44 over 2? 22. So basically you're telling me that the rate is equal to the square root of 22, which is 4.6, something like that. This is 4.69. There you go. Okay. So now this answer is technically the answer, but I'd like for you to do one sentence explanation summarizing what we have here, because sometimes you look at that number, there's no units, you don't know what it's talking about, right? So your final statement should be, who moves faster? Hydrogen gas. Hydrogen gas effuses 4.69 times faster than carbon dioxide. That is the final answer because that gives me some more meaning to what this number is referring to. So hydrogen gas effuses 4.69 times faster than CO2. Okay, so this is one type of question I could ask you here. I could say, here's some information, here's both of the gases, tell me their rate of diffusion or their relative rate of diffusion. Or I could ask you to find, I could tell you the rate of diffusion, I could have you backtrack to some unknown gas. Do you have a question first?
Yeah, so CO2 was in the top.
It would, the answer would be different, but then your statement would be different too. So if CO2 was in the top, it would be square root of 1 divided by 22, 0.213. So you would say CO2 diffuses at 0.12 or 0.213 times, because it's not faster, you'd say slower. It's like a fifth of the speed. Because that's almost 5 times faster, right? So it'd be like a fifth of the speed. It's just less. It doesn't make as much sense when you do it that way. I think this makes more logical sense. Okay, so let's do the other type of problem I could ask of you. Okay, so an unknown elemental gas. When I say elemental gas, I mean it's a gas that you can find on the PTOE in the non-metal section. Okay, so elemental gas is important. It uses 4.5 times faster. I'm sorry, the rate of krypton gas. First one is what's the molar mass, second one, identify the gas based on the molar mass, okay? So we have different information. We have the rate of diffusion is 4.5. What is the rate of diffusion equal to? What rate over what rate? Okay, rate A over rate B. Give me some value, or give me some names to rate A and rate B. So rate somebody over rate somebody.
Over rate.
Why are you saying that unknown is on top?
Because it's faster.
So it's
like,
there you go. So you have to put that together. It's saying that unknown gas diffuses 4.5 times faster, so it's the lighter one. So it's the one on top, faster than krypton, right? So krypton goes down low. Okay, that's equal to the square root of what over what? So what's the molar mass of krypton? I definitely can't see that number. How are you guys seeing these numbers? 83.8-ish, so you said grams per mole. Okay, over X. Good, you don't know this one. because that's what you're solving for, right? So we're solving for the molar mass of this unknown gas. All right, so 45 or 4.5 is equal to this square root thing. How do I isolate x? Square both things, okay, so square this and square this. So that gives us 4.5 squared, which is like 20.25 is equal to 83.8 grams per mole over x, because you're just taking away the square root, right? So now, so you just multiply by x on both sides. So that's essentially saying 20.25 x is on this side now is equal to 83.8 grams per mole divided by 20. Now, if you set it up and you're like, I got this Miss Emily 20.25 is equal to this over x, and you just go ahead and solve for x from your calculator, go for it. I am just walking through the baby steps for those of us who have not had this kind of math in a while. So x is 4 point something, 4.2, calculator, 83.8 divided by, so they may double check my math, is that right? I believe in myself, I'll go with it. 1, 4. Okay, once you get that, that is your molar mass, right? Now what can you do? Okay, so find who it is. It is helium. Good. It says elemental, so elemental means you have to find it that's closest from the periodic table of the elements, right? So, great, lots of fun, right? But why would this matter? I mean, I know everyone's birthday balloons could last for a long time. Why would this matter?
They don't.
Huh?
They don't avoid helium balloons for cherry.
Oh, so they. What do they do?
No.
They don't give away balloons? Okay, so that matters because they don't give away balloons. Why would this matter in the real world? Any examples? That's not the only reason. Who's ever been to one of the big parades that have the big balloons, like big float balloons? Macy's Day Parade? Think of yourself as a child, really excited to go to Thanksgiving Day, Macy's Day Parade. And you're just like, oh my gosh, so eager to see all the balloons, right? And this is what you end up seeing, not this, not this. Look, your dreams were just crushed. It was coming down, and then all of a sudden, the Easter Bunny, or the Energizer Bunny just flops. That poor child, they didn't know what to do with themselves. They hated chemistry from there on, until they learned that it was just somebody's dumb mistake of using the wrong type of gas, so they fused faster, and the bunny flopped. Poor children, yeah.
I know another example.
Yeah?
Like, they put nitrogen in tires now.
Yes, that's what I was looking for. I thought somebody would tell me about tire pressure. Because what?
Because it doesn't work as fast as...
I don't know if they used, what did they used to put in there? I know that it's 28 grams per mole now, but they have different masses to allow for different inflation and different rates of infusion when you think, because all tires leak just a little bit. So it matters when you guys start driving. Okay, cool. So here's what we are doing now. Oh, we got to check our map. So here's my game for the rest of it. We are, actually, let's do this first. You guys have ever played Kahoot?
Yes.
Go to Kahoot.com. We'll do that first. Now, Kahoot is a challenging game. It is competitive, so you're gonna have to hide your phones from each other's faces. I know.
Points to say one, but I didn't put my real name.
See, yeah, if you put Bootylicious, I will not know who you are, and I will not be able to give you more money. Okay?
What if I tell you? Yeah. What if?
I don't want to know if you're Bootylicious. I don't want to know. Give me some name that I'll recognize you as. The game pin is. So what you do is you go to Kahoot.it. Go to Kahoot.it. Choose the game pin is 51774. Choose some sort of name I can identify you as. Something.
What else? Maggie Rose, who's that?
The better version is that the next version. Oh, yes.
destroy your
It will. It will let you.
I did. I put little glasses in my phone.
Oh my gosh. Alright, take one more minute. Take one more minute. If you can't get logged in or something, go sit next to somebody. But this is for more money. Huh? Who is Jessica Enlow? I'll compete against you. I will. The real Jessica Enlow, please stand up. 19, there's like 30 of us in here. Where are my people? Let's go. Ready? Let's start when you're ready. That's HE. Okay, I'm starting in 20 seconds. Go team, let's go. 27 players. Should I?
Wait, that's the way he's at this. Wait, what? Oh, I think, wait, is he in the first period class?
No, it's okay. Hi.
Oh, wait, are you not next period?
I already did it with first period. I did it yesterday.
Are you going to do this today at all?
I mean, I have AP after this. This is it.
Make them so
They did this like in,
during Spanish.
they did this in like November. We learned gases so long ago. Okay, I'm starting in 3, 2, 1. Now, hold on. You realize that the answers are going to be towards the bottom. You might have to stand up in the back if you're short. Okay? Or you can scooch over here or scooch over here. I'm just going to be standing at the board. If you can't see, we'll set the lights off, okay? So, this is for extra credit, people. Let's get serious here. And we have 20 questions.
Can I like take pictures?
No. You ready? The water droplets that appear on the steam top window are produced by 10 seconds. I'm going to turn music on. 5, 4, 3, 2. I know, I gotta put the music on, I just forgot. Okay, yeah, this is fast. Condensation too. What? What? Okay, I gotta turn the music up. Woo! It's like Nick. This is not the same without the music. Okay, here we go. This is fast. The law is represented by the picture below. What law? Yeah, look at the picture. I know. What? Sorry. P and B. Thank you, 9 people. Thank you. P and B. Okay, sorry. Gotta get turned up here. Kayla, which of these can be easily compressed? I don't know who copy is. Which of these can be easily compressed? Out. Thank you. Thank you. People, can you crush? I want to see you crush a solid. No.
I mean,
What would happen to the pressure of a gas in a steel tank if it was heated? Good job, guys. So, increasing kinetic energy bounced off the container. I'm rolling. What? Here we go. 3, 2, 1. Which of these takes the shape of the container it's in? I'll take 2 answers on this. Okay. It depends on... I have to explain this one. So most of us did get that right, but if you chose gases only, I'll go back and give you credit later. Just not right now. That one is, especially if the volume of the liquid is large, it's going to obviously take the shape of the container, right? So you got to kind of think bigger on that one. Copy. Good. Temperature and pressure are blank related. Good. Increasing. So whose law is that? Whose law?
I'm gonna guess.
Whose law?
No.
Third one down.
20. Gay-Lussac's. Which one? Nope. A gas will always occupy the total volume of a container. Yeah, so like. Yay! Yay! What? No, gas is always contained. No. No, nay people. No. Yay, Gianna. What would happen to the volume of a gas in a balloon if it was heated?
Boom, pop.
Look. Good job. Who is Jessica Inlow? I don't know who you are. I will take the more money. I'm good with that. But good. The pressure increasing will actually cause the balloon to expand if it's heated. Kayla, what is STP?
Come on.
Good Lord. Same temperature. Breathe, people. Breathe. Going. Oh, sorry. I didn't mean to go that fast. Which state of water do the particles move about most freely? Please tell me which was gases. Thank you. No. Where's Jessica Inlow on here? Let's go, Jessica Inlow.
Nice.
What is there between the particles in a gas?
Oh my gosh.
Yes. Good. You did not choose air.
No, I chose that. I'm saying. I'm only 50 behind.
There you go, girl. Okay, you ready? Set. Gay-Lussac's law describes the relationship between. We just did this. Where are the people? I don't know how it works for you. If it doesn't load, can you still answer the question?
No.
If it doesn't load, period.
It did that to me.
It loads.
It's really late.
Oh, so that Wi-Fi. Get on that Verizon or whatever. There you go. That Wi-Fi. Ready, set, go. If the pressure of a gas goes up by 5 times, the new volume will be. Hey. Oh gosh, no. Okay, so stop for a second. I have to explain this one. Ready? I'll wait on you. If the pressure goes up 5 times, then you know the volume is inversely related, right? So it should go down to a fifth. So if you multiply the pressure by 5, the volume goes down by the same ratio. So if you multiply the same, that means you're directly related. No, they're indirectly related, so it has to be a fifth of the volume. Okay, you'll see some of the stats come on your test. And now you're on the board. Based on Boyle's law, the volume increases from 20 to 60 liters at 60 atmospheres. Pressure. I'm out. Ooh, gosh, 50% again. All right, somebody explain this. Raise your hand.
Okay.
Go for it.
Since it goes up from 20 to 60, like 40 difference. It's inversely proportional, so it goes down 40 from 60.
Okay, so similar, you could explain it via proportion. So it triples in liters, right? Triples the volume.
Right.
So it 1/3 the pressure from 60 to 20. It's the same proportional that we just did a second ago. Okay. Lewis, good job, man. Keep going. What would happen to the pressure of a gas inside a syringe if you compress it? Yeah. Who are you, number 1? No. Just gonna somebody's screwing me over, man. The ideal gas law constant R is
Oh, great.
Look closely. You just gotta look at the decimal. Look at the decimal. I'm not going over that one. Look at the decimal. What are the conditions at STP? What are the conditions?
Zero Kelvin.
Who's no? You guys, hopefully you're learning something from your mistakes. I'm not going to call you out fooling people.
Yeah, I'm the one with the.
Okay. Yes, keep going, people. Let's knock one of these people out of the lead. Yeah?
No.
Let's go, team. Sleeping ZRT is known as a combined gas law. True or false? What is that called? Ideal gas law. You ready? When using the ideal gas law, volume must be in. Dang, you guys are fast. Good. No, people. No. Go, Gianna. To convert degrees Kelvin to Celsius. Please tell me. Okay, good. So yeah, Kelvin to Celsius, you subtract. Good. Gianna, rocket girl. Oh, Gianna, woo! Okay, let's do the top 5 word.
Let's do top 10.
Top 5. Gianna Lewis. Where is Jessica Inlow on here? Who is Jessica Inlow? She's an A. Dang it. Come on, Gary, just represent. Okay, Air 5 to Gianna Lewis. Copy. Sarah. Which Sarah? Sarah? Oh, yeah, that's right. Sorry. And Jack. Woo! Okay. More money. I'll give you more money.
Where's the emoji?
I don't know. Okay, so for the rest, we have an hour left. Let me tell you your 3 options. Okay, you can do them. I'll wait on you.
I'll give you 1 star.
You can do 3 things at this time, but if you want to listen to me review 1 through 5, that's what you'll have to sit up here for, okay? So, one thing you guys are going to be doing is making a foldable based on the gas laws, because instead of doing the web quest, that's actually this is a better study tool, I guess. So, I have some instructions on here, but I will tell you for the step 3, you will choose only 3 bullets to do. There are 5 or 6 bullets to choose from, it's like details about the gas laws, but you're only going to choose half of them, 3, okay? So, one of those is the foldable. The other one is to... We're not going to do QRs. The other one is to finish up problem set 14 and start unit review. And then I will be going over questions numbers 1 through 5 from the ideal gas law. And I'm taking that up in your portfolio check. So if you don't have them done, then I would make sure you sit up here with me. Okay? So the instructions for... I'll put them back here. The instructions for the foldable, you guys can get on my paper accessible over here. You can make the foldable in whatever way you want. I'm not sure on physics reading. The foldable instructions are here. They're also on my website. This is due on test day. So if you don't finish today, so it's fine. You'll have tomorrow as well, in addition to the review. So it's mainly up to you how you're using your last hour of time. Is that ideal? Okay. On step 3, you're only choosing 3 of the bullets to do your choice. You can sit down constantly, work with somebody, that's fine, but please stay on top of it all the time, because you know we just want to that's it. So if you want to do 1 through 5, I think that's possible. That's right. Otherwise, yeah.
number 9.
Tell me which one you can do now that you know what grams are. 9 we just talked about yesterday. Don't until yesterday.
Yeah.
Yeah?
Well, yeah, besides 9.